Hi, everybody. This is Mr. Folly, and welcome to podcast 4.4, the effects of intermolecular forces and sticky particles. Explain how intermolecular forces explain the state of matter of a substance at room temperature. Define viscosity and explain how the strength of intermolecular forces relates to viscosity. Define volatility and relate the strength of those forces. State that intermolecular forces are only between molecular compounds. They do not exist in ionic compounds. Describe the unusual properties of water, including blah 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 blah, and explain the cause that causes H bonding. Say the two atoms of molecular polarity, our state, our bond polarity and molecular shape. So let's do it. All right. So, come on. There you go. Intermolecular forces determine the state of matter. Strong forces hold together better. The strongest forces are solids because they're held together. Look at this. They are so tightly held together. Oh my goodness. You can't separate those if you want to. Weakest forces are gas. Remember, gases shoot all over the place, so who knows which way they're going, and they're barely attracted to each other at all. Liquids are attracted enough, but they have enough energy they roll all over the place. Okay? So the strongest forces are hydrogen bonds. That'll most likely be a solid. The middle forces are dipole-dipole. It's hard to predict those. And the weakest forces are dispersion forces, most likely a gas. Remember, the tiebreaker is dispersion. Big molecules can have big dispersion forces. And I talked about in some classes how butter has enormous dispersion forces because it's an enormous molecule. Predict the state of matter for each of these. So if I see OH, I go OH. Oh, that has H bonding. So if I have H bonding, I would expect it to be a solid. C to H. Now, I remember, do you, that C to H is a nonpolar bond. If not, I get out my professor periodic table and see that the difference between the two is something like 0.35 or so. So that means it's a nonpolar molecule, so it has dispersion forces only. So this, I guess I'm making a table. These are my forces. Woo, woo. This is my state. Woo. So if it's dispersion only, it would be a gas. H to F, H to F, H to F. Hey, that's H bonding. H bonding is the strongest, so I would guess it is a solid. Now, in reality, these guesses might not be right, but they're good for ranking these things. OF2. For OF2, I think I have to draw a little bit of it. Oxygen, dink, 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 dink. And if I gave you the structure, which I would, that looks like this, I would look to see that O to F is a polar bond. It's a polar bond, and do you see that my polarity doesn't change? Right? My polarity does not, it's not canceled out. Right? So if I drew my little arrows, hey, I drew the arrows. The center of negativity is here. The center of positivity is here. So it's a polar molecule. So if it's a polar molecule, it's in the middle. I'd guess liquid. But what do I know? But that would be why, because it's the middle part. If I had to compare these two, I would say this one is more likely solid. More likely solid because it weighs more. Weighs more? What? Well, look at it. It's bigger, right? Bigger. C6H6OH. That's a big molecule. That's a little one. Okay. Viscosity is resistance to flow. Strong forces increase the viscosity. That's a slow flow. So if you look here, quick flow, a little less, slower flow. Notice how this one goes here, and this one goes just a smidgen. Okay, so this one would be the most viscous. Okay, so it's the slowest moving. So it's the most viscous. It has the strongest forces and the slowest flow. So this would be H bonding, and this would be dispersion only. Okay, and the weakest forces decrease the viscosity, which would give it a fast flow. And I talked about how there's a book, Dark Tide, how a building blew up and swamped everybody with molasses, and they died from being covered with molasses. And molasses is very viscous. And there's extra credit for reading that book if you write the little book report too. Volatility is the ability to evaporate. High volatility means a liquid turns to a gas easily. So that means low intermolecular forces. If it turns into a gas, that means it's not very attracted to itself. Low volatility, liquid stays liquid because it loves itself. Like Jaquan. Jaquan's favorite topic to talk about is Jaquan. Right? So the strong intermolecular forces, it loves itself. It stays a liquid, it stays together. Surface tension. Liquids, if a liquid is very attracted to itself, that is surface tension, like Kiara always looking at herself, and will not react with other types of molecules. Okay, it'll form a dome. So do you see how these particles are all attracted to themselves? So because they're so attracted to themselves, they pull inside and make a dome. If they were not attracted to itself, this particle would fall here, this one would fall here, this one would fall here, this one would wiggle in here, and an unattracted, weak forces have little surface tensions, flat, to be one molecule thick. Whoops, thick. And if it's a strong force, I can drop something in here and my surface tension could actually hold it. Okay? So surface tension says the liquid has this would show a strong surface tension. If it was a weaker surface tension, this thing would go all the way through. Ionic compounds do not use intermolecular forces to determine state, volatility, or viscosity. Ionic bonds hold each ion together, which is much stronger. I suppose that should be like a semicolon. So now remember, it's much stronger. Strong, 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 strong. No. Held together. Too strongly. Are they very viscous? Viscous means resist flow. Are they very viscous? Yes. Held together. Therefore, resists flow. Are they very gassy? Oh, excuse me. No. They're held together. So, solidy, if you're going to do that weird little thing. Boop, boop, boop. Melting point and boiling point. Okay. Strong forces make a boiling point go up because the particles are so attracted to each other, they stay a liquid. There's a little bio flashback for you. How about that? Yeah. Strong forces make the melting point also go up. And my voice cracked too. Because the particles are so attracted to each other, they stay a solid. Remember how solids are compact and stick together even more? Water has H bonding, which is really strong. Because it has H bonding, which is really strong, water has a high surface tension. Why does water have a high surface tension? It has H bonding. Water has a really high viscosity. Why does it have a really high viscosity? Because of H bonding. Water has a really high boiling point and melting point. Why? Because of H bonding. Water has a very low volatility. Why? Because of H bonding. And this is for its mass. Remember, dispersion forces can even things out. Bigger molecules have tons of dispersion forces, so their values can be higher. So if you said, hey, syrup has more viscosity than water, why is that? Well, syrup must be a bigger molecule. Much, 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 much bigger molecule. Water is one of only two solids that are larger when they are frozen. So if you freeze water, see how there's a big empty space in here? It will actually make a can erupt. So that doesn't happen very often, but water leaves a big empty space when it freezes. Most things when they freeze stack up. We know water looks like Mickey Mouse, right? And you would think if you want to have it be tightly compacted together, it would look something like this, a bunch of Mickey Mouses stacked on top. But it's not, because the hydrogen bonding, see how this hydrogen bond here attracts it to go through it. Molecular polarity is found by two factors: bond polarity and shape, which comes down to whether it cancels or not. Bond polarity, this is the first and foremost one. If nonpolar, nonpolar. If nonpolar bond, molecule must be nonpolar. But if it has a polar bond, it must have a shape that does not cancel the polarity. So there we go, H bonding again. H bonding is strong. It holds particles together. Intermolecular forces affect the state of matter, boiling point, melting point, viscosity, volatility, density of solid. Ionic compounds use ionic bonds for state, boiling point, melting point, viscosity, volatility, and density of the solid. Covalent compounds do not use covalent bonds to find these properties. And Lionel Richie is stuck on you. Toodles.